I'm Matt Nevis, and I'm the team lead for the Sandia National Labs Competition Team. In this year's challenge, Humpty Dumpty has taken a great fall without anything to protect him from impact. So Sandia National Labs has tasked New Mexico Tech with designing capsules to protect future Humpties from suffering the same fate. A battery of tests will be performed in order to ensure future Humpties' safety. These include a vibrational test, a thermal test, a compression test, and a drop test. We have had resounding success with our design and are excited to compete on behalf of New Mexico Tech.
Hello, my name is Zachary Richardson and I oversaw the thermal testing. The thermal testing was the least strenuous of the tests and had Humpty be cycled from negative 25 to 80 degrees Celsius. With heat transfer analysis, we were able to calculate a minimum wall thickness of both the TPU insert and outside shell with fiberglass inlay to not allow the paintballs inside to melt. We were given access to a thermal testing chamber thanks to Iris Pascal. This gave our team the ability to perfectly replicate the test that will be done at competition. The Humpty ultimately survived the test with no scratches.
Hello, my name is Jacob Nikolai, and I work primarily on mitigating the vibrational energy felt by the insert. The testing conditions of Sandia are 7 GRMs at about 10 to 1000 Hz, which we could replicate in 10-second periods using a shockless U-Haul trailer. We analyzed different infill percentages, patterns, weights, and print conditions to maximize energy dispersion, but allow deformation to allow the impulse to be less concentrated. Our end design survived roughly around 75 Gs of acceleration at its maximum.
Hi, my name is Mia Walker and I'm the head of compression testing. For compression testing, we compressed our Onyx capsule to determine the max load. In competition, we needed to withstand a minimum of 500 pounds. It performed extremely well with a max load measuring around 3,200. We also tested ornaments and paintballs in the same manner to find a base of where we would be with the load of the two components could withstand. After a full compression test with the ornaments and paintballs inside of the capsule, they still did not sustain any damage whatsoever.
Hello, my name is Joe Novak and I'm the Team Safety Officer. I also helped design our capsule to protect Humpty from a 100-foot drop. The main event of the Sandia National Labs Capstone Challenge this year is a 100-foot drop test. This test is one of the largest sources of points in the competition, so we placed a large emphasis on this part of the design. We tested several design concepts for our capsule early in the fall semester. Final design incorporates many of the key aspects of those early concepts. Once we determined that our capsule would fly stably, we focused our efforts on protecting Humpty to the best of our ability. We designed the nose cone of our capsule to absorb as much of the impact energy as possible, resulting in a thin-walled construction. Our first physical tests have indicated that the capsule does an excellent job protecting Humpty, and we are very confident in our design as we prepare for competition.
I'm Derek Plummer. I'm the procurement officer for the team, and these are the material choices made for our capsule. Since all components need to be 3D printed for this, material choices were limited to filaments. The capsule has 3 different sections, the inner and outer shells, as well as the cone. These cost approximately $23, $57, and $17 respectively. The cone and outer shells are printed with a carbon fiber infused nylon, otherwise known as Onyx. These were printed at 40% infill. The outer shell was also infused with a fiberglass fusion every 1 centimeter vertically, as this increased the strength by 2.5 times and the rigidity by 7 times, which suited our needs for the compression and drop tests. The inner shell was printed with TPU at 20% infill in order to maximize the vibrational dampening and thermal insulation. A cap was also printed in order to secure the capsule, bringing our total cost to $116.